This right here is the $350 million Millenium Tower. It's one of the tallest residential buildings in San Francisco with 58 stories and 419 luxury condos. Opened in 2009, it was supposed to be the symbol of luxury and architecture until it started making headlines in the news.
The saga continues. It's not just a headache for city officials and homeowners. It could also be a risk in an earthquake. How will the leaning and sinking Millenium Tower stand up in a major quake? Will the recent renovation actually make it safer? Here's NBC Bay Area's investigative reporter, Jackson Vanderbecken.
The building started sinking and tilting at an accelerated pace. The residents started to notice that the furniture wasn't level. The floors were becoming uneven. Cracks were being noticed in the foundation walls, and the internal utilities like the elevator doors were not aligned anymore. Nevertheless, millions of dollars are poured into the design and construction of these mega structures. However, accurate soil settlement prediction under these massive structures is really complex. In this video, I discuss how and why buildings settle, the mechanisms of soil settlement, the effects settlement poses on the structural stability of buildings, and how geotechnical engineers deal with soil settlement. My name is Clemens, and welcome to Geotechs with Clemens. Modern skyscrapers are constructed with a combination of steel and concrete. Steel is a good material at resisting pulling forces experienced by structural members. For example, the deflection and the buckling loads of beams and columns. On the other hand, concrete is good at resisting compressional and shear forces acting on the building overall. Though concrete is responsible for carrying the brunt of the structural loads, the downside is that concrete is heavy. Extremely heavy. With concrete aggregates, sand and cement paste, concrete makes the majority of the tremendous load subjected to the foundation. These heavy loads causes a downward movement on the ground in a process called settlement. But what is this settlement, right? And how does it happen? You see, settlement can be divided into two. The immediate settlement, also commonly referred to elastic settlement, and consolidation settlement, also known as long-term settlement. I want you to imagine a huge container with infinitely rigid walls. Now imagine filling this container with loose soil. Let's say this represents uncompacted ground. Now, let's take it a step further and add a building on top of our hypothetical container. As the soil is subjected to extreme loads during the construction of the building, the soil particles will start to rearrange to occupy all the void spaces. This results in a downward displacement of the ground, causing the initial settlement, also known as the immediate settlement. Now, let's add some water in our model. And let's say this represents our groundwater table. Frankly, this poses a whole lot of problems for the design and construction of buildings. You see, water is incompressible under normal conditions. In our ideal model, the water is not allowed to flow past the boundaries of the system. This means both the soil particles and the water in the void spaces will carry the load from the building. However, if we allow the water to freely flow out of the system due to the applied pressure, the soil particles will freely rearrange to occupy the voids left behind. This process is what we call consolidation of soil. This dissipation of water in the voids will cause the ground to subside as a result. Consolidation is a function of time, and it is divided into two parts, which are short-term and long-term consolidation. This means structures can take years, if not decades, to fully settle. Just as a side note, consolidation is heavily influenced by the permeability of the soil, which is the measure at which the water is allowed to pass through the soil. This controls the rate at which the ground will consolidate and settle. For example, cohesionless soils like sand have a higher permeability that allows a free flow of water between the particles, in comparison to clays and silty clays, which have a tightly packed particle matrix that reduces the rate at which the water dissipates. This means buildings will take a longer time to settle in clays than the buildings which are built on sand. The amount of settlement of heavy structures can be anticipated. You see, geotechnical engineers can calculate the theoretical approximate settlement during the design phase. This can be achieved by the use of finite element analysis software, laboratory tests on samples collected on site, and the analytical models. However, if the settlement exceeds the predicted value during and after construction, major problems will arise. Foundation walls will start cracking, leading to leakages. Building utilities like water, sewage piping, and ventilations might get damaged. And in worst-case scenarios, the building will tilt due to uneven settlement, just like the challenge facing engineers working to fix the Millenium Tower. The building frame might stretch, twist, buckle, or the combination of the above, leading to overall structural stability problems. There are actually several methods that are used to reduce ground settlement of tall buildings. One method is foundation remediation by concrete underpinning. Another method is foundation remediation with jet grouting. A third and the most common method is the installation of micro and macro piles to support the structure. There are two types of piles that can be used, that is, the end-bearing capacity piles, which are drilled or installed until they reach the bedrock to transfer the superstructure loads. The other type is the skin friction piles. These use the friction between the interaction of the pile surface and the soil to support the structure. There are other non-permanent methods that can be utilized beforehand. This might include preloading or pre-compression. This process involves placing additional vertical stress on the compressible soil to remove the pore water over time. The pore water dissipation reduces the total volume, causing settlement before the building is constructed. In other words, this is pre-consolidation of the ground. In conclusion, all tall buildings settle or sink, however you want to call it. But geotechnical engineers work tirelessly to make sure that all the infrastructure around us is safe and comfortable to use. Yes, you might come across some leakages in your basement here and there, but mostly the overall structural stability of the building is safe. If you have enjoyed this video, please subscribe and hit the like button. I would really appreciate it. Until next time, cheers.